In this video, we are getting practice looking at the trigonometric formulas and how we can use them. By the trigonometric formulas, what I have in mind are the formulas that you can find on the reference sheet, and this is a reference sheet that is also available on the back of the Regents exam. Especially, we're looking at some of these. These are not formulas that you have to have memorized. These are formulas that you just have to be comfortable with and be able to choose the correct one when you need it, substitute and simplify to try to get the answers that it's looking for. So let's read what this question is asking for. It tells us that given that A and B are second quadrant angles, the sine of A is equal to 1/3, and the sine of B is equal to 1/5, it wants us to find what is the cosine of A minus B. These are two angles, and it wants to know what is the cosine of this angle minus that angle. So, for problems like this, where we're working with trigonometric formulas, the first step is, which formula should we use? To decide that, we look at the reference sheet and we see if there's a formula on the reference sheet that includes what we want to find. So take a look at the reference sheet. You should have one with you as you're watching this. As I look at this reference sheet, I notice, you want to take a look at all of them, but I notice that right here on the reference sheet, there is actually a formula that tells us that the cosine of A minus B is equal to the cosine of A times the cosine of B plus the sine of A times the sine of B. I'm sure that's a bit blurry for you on the video, but you should have a reference sheet that you can use to verify that that is exactly what it says. So returning back to the problem, since what we want to find is the cosine of A minus B, there is no doubt that this is the best formula on the reference for us, and so we'll just write that formula down. So that formula says that the cosine of A minus B, what we want to find, is equal to the cosine of A times the cosine of B plus the sine of A times the sine of B. I did not have this memorized, and you don't have to have it memorized. I got this by looking at the reference sheet and finding a formula that best suits what we're trying to find. Now, once we have found which formula is best, we'll go to the second step, which is to figure out what values do we know and take a look at what values will we need. And what we mean by what do we know and what do we need, I mean, look at this formula. What do we know already that is used in this formula? Well, the problem tells us what the sine of A is, and we need to know the sine of A, so that's something that we know. We know the sine of A is equal to 1/3 because that is something that was given to us. We also know that the sine of B is 1/5 because that was given to us. In the formula, is there anything that we're going to need that wasn't given to us? Well, in order to use this formula, we have to know the cosine of A and we have to know the cosine of B. So those are things that we're going to have to find. What are these values? Well, the good thing is that whenever we are told the sine of an angle, it's not too hard to get the cosine of the angle, because we can use this nice Pythagorean identity that we have used several times now. We know that the cosine squared A plus the sine squared A has to be equal to 1. And since we know this, because it was given to us, we can use it to solve for this, which is what we want. So we'll write here the cosine squared A plus, instead of sine squared A, I'm going to write 1/3 squared is equal to 1. 1/3 squared is equal to 1/9, so this is cosine squared A plus 1/9 is equal to 1. Now we will subtract 1/9 from both sides, and we get cosine squared A is equal to 1 minus 1/9 is 8/9. Now we'll take the square root, so we have cosine of A is equal to plus or minus the square root of 8/9, which is equal to plus or minus the square root of 8 over the square root of 9. The square root of 9 is 3. Radical 8 can be simplified into 2 radical 2, so this is equal to plus or minus 2 radical 2 over 3. What should we do about this plus or minus? Well, that is the reason that they told us that this is a second quadrant angle. The second quadrant is right here. All of the x values in the second quadrant are negative, which means that the cosine is negative in the second quadrant, and that tells us that we should be using the negative sign, and so the cosine of A is equal to a negative 2, radical 2, over 3. And now we have another of the values that we'll need to use this formula. What are we still going to need? So we don't need the cosine of A anymore. We still need the cosine of B. So we'll find the cosine of B by using the same idea. So we have cosine squared B plus sine squared B is equal to 1. So the cosine squared B plus, what do we have here? Oh, the sine of B is 1/5. So this is 1/5 squared is equal to 1. So this is cosine squared B plus 1/5 squared is the same thing as 1/25 is equal to 1. I'll subtract 1/25 from both sides, so cosine squared B is equal to 1 minus 1/25 is 24/25. Take the square root of both sides, so we get cosine of B is equal to plus or minus the square root of 24 over 25. We'll have to simplify this radical 24. Well, radical 24 is the same thing as, 4 times 6. The 4 breaks into a 2 and a 2, and the 6 breaks into a 2 and a 3. So we end up with radical 2 times 2 times 2 times 3. There's a pair of 2, so this is 2 radical 2 times 3. This is 2 radical 6. So we get the cosine of B is equal to plus or minus 2 radical 6, 2 radical 6, over, what is radical 25? Well, that's just 5. And it tells us that B is also a second quadrant angle. And since it is a second quadrant angle, that means that we want to use the cosine of B is equal to the negative 2 radical 6 over 5. And so now we know the cosine of B as well. The cosine of B is negative 2 radical 6 over 5. Well, now we know everything that we need to use this formula. The rest is just the third and final step, which is to substitute and simplify. So we're going to substitute these values that we have just found into the formula. Let's do that right now. So again, here is the formula. The formula that we're using is the cosine of A minus B is equal to the cosine of A times the cosine of B plus the sine of A times the sine of B. We know many of these values, so the cosine of A minus B is equal to, what did we find for the cosine of A? We found that that was negative 2 radical 2 over 3 times, what did we get for the cosine of B? Well, the cosine of B we found was negative 2 radical 6 over 5 plus the sine of A, we were given that is 1/3. The sine of B, we were given that was 1/5. Now we have substituted, now we just need to simplify. So let's multiply this radical expression times this radical expression. To do that, you multiply the coefficients together. Negative 2 times negative 2 is 4. Radical 2 times radical 6 is radical 12 over 3 times 5 is 15. This can be simplified, but we'll do that later. 1/3 times 1/5 is 1 times 1 is 1, and 3 times 5 is 15, so this becomes 1 over 15. We're nearly done. Let's simplify this 4 radical 12. We'll do it right here. So 4 radical 12, the 12 breaks into a 3 and a 4. 3 is a prime number, but 4 breaks into a 2 and a 2. So this is 4 radical 2 times 3. Here we have a pair of 2's, so a 2 comes out, so it's 4 times 2 times radical 3. This is 4 times 2, so that's 8 radical 3. 8 radical 3. In other words, 4 radical 12 is the same thing as 8 radical 3. So this becomes, instead of 4 radical 12, I'll write that as 8 radical 3 over 15 plus 1 over 15. These already have common denominators, and so we end up with 8 radical 3 plus 1 over 15. This cannot be simplified anymore, and so the final answer is the cosine of A minus B is equal to 8 radical 3 plus 1 over 15. And there is our final answer.